Well, hello everyone, and welcome to the webinar Adventures in Crowdsourcing, Open Source Code to Jumpstart and Analytics. My name is Kevin Vita, and I'll be helping with facilitating today's webinar. This webinar is sponsored by the Federal Highway Administration and hosted by the National Operations Center of Excellence, also known as NOCO. As a quick reminder, if you don't know already, at NOCO we offer a variety of resources to support the transportation systems management and operations community. On the lower right side of your screen, you can see a box called Useful Links. You can browse through those links for TSMO resources and news. Previous webinar recordings related to this topic can be also accessed there. Now I'll cover a few logistics for today's webinar. We are recording this webinar, and the recording, along with the presentation slides, will be available through the on-demand learning section of our website. All the attendees are in listen-only mode by default, but we'd like you to stay engaged by using the question and discussion pod for comments and questions. We have a Q&A session at the end of the webinar, so if you have any questions, we encourage all of you to enter them in the questions pod as they come to your mind at any time. The questions will be read out loud one at a time by the moderator, and our presenters will answer your questions. So that's all I have, and with that, I'll hand it over to our moderator, Ralph Volpe, to start us off.
Thanks, Kevin. All right, let me go back to the beginning of my screen here. Good afternoon, or for those of you in the Western time zones, good morning. My name is Ralph Volpe, and I am a Transportation Systems Operations Specialist with the Federal Highway Administration Resource Center. I'm on their Operations Technical Service team. And I'm also one of the co-leads for the FHWA Everyday Counts Round 6 of Advancing Crowdsourcing for Operations. In collaboration with the National Operations Center of Excellence, I'd like to welcome everyone to another edition of our Adventures in Crowdsourcing webinar series. Today, our topic will focus on open source code to jumpstart analytics. But before we begin, I want to share this disclaimer that the U.S. government does not endorse products or manufacturers, trademark or manufacturers' names as they appear in this presentation, only because they are considered essential to the objective of the presentation. They are included for informational purposes and only are not intended to reflect a preference, approval, or endorsement of any one product or entity. This presentation was created and is being co-presented by the Federal Highway Administration and the individual presenters. The views and opinions expressed are those of the presenters and do not necessarily reflect those of the FHWA or the United States Department of Transportation. The contents do not necessarily reflect the official policy of the U.S. DOT. So let's begin. For today's webinar, I want to share a few tidbits of our crowdsourcing effort as part of the Federal Highway Administration Everyday Counts program and how it relates with today's topic. We also have two presenters, and from a change, they're from two municipalities, but they've made advanced uses of using open source code to integrate crowdsourced data into their everyday traffic operations management. Following our presentations, we'll have a question and answer segment, but we're going to do this with a twist. And not to kind of steer away from concentration on municipalities and the use of open source, but we want to give state DOT some perspective as well. We invited Chris Lambert from the Kentucky Transportation Company Cabinet to kind of add to the discussion, and we may even have Ben Pichot, who's a contractor with our Everyday Counts program, to kind of give some thoughts about involving data integration and analytics as well. As mentioned during the title slide, I'm Ralph Volpe, and I will serve as the webinar host. Behind the scenes, I'll be supported by two of our contractors, Grady Carrick and Amir Arista. And since this topic aligns with another Everyday Counts innovation, next generation of traffic incident management, You may hear Grady share some common tidbits to support that innovation as well. Our first speaker will be Monsur Ahmed. Monsur is with the City of Arlington, Texas, and is a registered professional transportation engineer with certificates in Texas and Washington State. As the Assistant Director of Public Works and Transportation, Monsur oversees the traffic engineering, infrastructure development, and construction management for the City of Arlington. His expertise spans transportation systems and facilities design, ITS, traffic signal systems, simulation modeling, and smart city projects. Our second speaker is Ryan Legare. Ryan has been with the Lake County Division of Transportation for over 12 years, with the most recent 6 years as their Traffic Management Center Manager. His experience includes maintaining all core ITS equipment, creating various programs for processing traffic counts, archiving the Waze travel times, and redesigning smartphone applications for the Lake County's passage system. Ryan holds a bachelor's degree from Northeastern Illinois University. So what is Everyday Counts? Consider the Everyday Counts program as a state and locally based model to deploy proven yet underutilized innovations to shorten project delivery, enhance roadway safety, reduce traffic congestion, and integrate automation. The Advancing Crowdsourcing for Operations innovation is one of 7 innovations in our round 6 of Everyday Counts. But it is also the only innovation that was carried over from the round 5 of Everyday Counts. So why crowdsourcing for operations? And many of you have heard this before, but as a quick refresher, there are many types of crowdsourced data. Vehicle probe, navigation apps such as Waze, states, 511 systems, or local agencies that we're seeing many with 311 applications, connected vehicle data, and as we highlighted during last month's webinar, crowdsourced video analytics from fleet, shared mobility, and public vehicles. These data help transportation agencies and incident response agencies to improve operations and customer services with greater and more timely geographic roadway monitoring. Another is increased safety and reliability of the operations, as well as inform infrastructure enhancements for safety. And finally, improve the cost basis for operations and asset management by reducing operator workload, retiring ITS assets that are costly to maintain, and balancing infrastructure investment with crowdsourced data for enhanced system monitoring. These benefits can be seen through many operational lenses. We call these crowdsourcing application areas. The low-hanging fruit for most agencies has been the traffic incident management and traveler information. But today we're going to talk analytics, and we're finding uses with traffic studies as well as analytics that support performance management. And combined with real-time operations, we're in a better place with road weather management, arterial management, which we'll learn a little bit more in a few moments, and freeway management, work zone management, and emergency management. These applications help local and state agencies to explore other valuable areas of operations to help support their effort in transportation systems management and operations. One last slide before I turn the platform to our presenters. I just want to share on two initiatives our crowdsourcing for operations has, and that's the Cohorts and Innovations Outreach. First, we have 3 cohort groups: vehicle probe data use of crowdsourcing analytics tools, and how to make better use of free navigational app data to support systems management. During the next 2 months, we'll welcome you to join 1, 2, or all 3 of these cohort meetings. First, we have on October 13th the vehicle probe data cohort, and then the very next day, on October 14th, is our crowdsourced analytics tools cohort. And then to round out round 2 of our cohorts, the free navigational app data cohort meeting will be on November 1st. Another type of effort that we kind of want you to think about is how we could kind of best serve your associations that you belong to. Our innovation outreach efforts recognize and respect those in associations, including your very own state chapters. It could be from ITS America or through your section or state ITE. We welcome to support your meetings with a spot on your agenda, and we can tailor the presentation to meet the needs of your association. So why don't we go ahead and get started? I'd like to, if we could, Kevin, switch over to Monsur's presentation. And by the way, before Monsur begins, we'll have an opportunity for questions and answering following both of our presenters. But in the meantime, when you do have a question, please feel free to add that into the question discussion pod to the right of the presentation screen. So with that, I'd like to bring Monsur Ahmed, who's now with the city of Arlington, Texas, and who was, some of you may know Monsur. He was with the city of Irving prior. So Monsur, it's all yours.
Thank you, Ralph. Hello, everyone. This is Monsur Ahmed. As Ralph introduced me, I am currently the Assistant Director for Public Works and Transportation with the City of Arlington. Previously, I was Traffic Engineering Manager with the City of Irving, Texas, and I just switched the job last week. So that's why the presentation is kind of in between the transition. Today's presentation is mostly about how it was implemented in the City of Irving, the crowdsourced data application from the Lake County developed. So, but later on, I'll also give a little bit of introduction about the City of Arlington and what is City of Arlington's plan to do with that as well. So giving you a little bit of background of City of Irving, Texas. It's a mid-sized city in the Dallas-Fort Worth Metroplex area, but it's placed right between the Dallas and Fort Worth, the two largest cities in the DFW Metroplex. So, which gives actually the Irving a lot of commuter traffic. As you can see, there are many freeways crossing Irving. There are a lot of arterial corridors, but a lot of the traffic are pass-through traffic for commute purpose on different cities as well. This is kind of the City of Irving's Traffic Operations Center, which manages the city's ITS infrastructure. Currently, the city has 210 signals, 140 video detection systems with remote monitoring capabilities. All are connected to the TMC, and then 47 additional PTZ monitoring cameras on major corridors and some of the freeway service roads. Most of the city's network are built in on the wireless radio network, but overall, all this video feed and the signal data and everything were coming through that wireless network, and TMC was operating very good with the network. The city was using the MaxView, Intellite MaxTime traffic signal controllers and MaxView signal system, which had a built-in automated traffic signal performance measures, which was giving high-resolution signal performance measures data for all the signals, and which was a great tool to have. So there are a lot of analytics already been going, and performance analytics on the signal timing. So there was definitely a lot of real-time signal timing adjustment happening at that time. But one of the things that we kind of felt the need is that we need to complement that high-resolution data with travel time information, speed information on the corridors, and city didn't have any other third-party data subscription, but city is a Waze Connected Cities Partner, so which was giving some sort of data, which was giving some congestion alert when this happening on a major freeway, which is also giving the Waze traffic view tool. So we had 24 different routes program in the Waze traffic view tool. So that was giving a real-time travel time monitoring capability. But we didn't have is that to store that data in the historic data pattern and kind of use that historic data for before-after analysis or for other purposes. So Lake County Development Polar application, we came to knowledge from our DFW Metroplex Council of Government organization, and then I contacted Lake County Ryan and got to know the process, how to implement that, and it's a pre-program open source code. So, and I got to know the process. It seemed to be very easy to do that, and definitely it has a user alert system that you can set with the travel time threshold that sends alerts, and it records the historic data. So it definitely meets the needs at that time City of Irving was looking for. So we started going through the process to implement it, and the whole implementation process is very easy to do, even though at the first, implementing it, I had to coordinate with Ryan on a couple of occasions, but we also got to get help from Lake County on that part. So the first step definitely need to be a Waze CCP partner. City of Irving was already in that. Needed to have the traffic view tool, so to get that traffic view data. Then in the traffic view tool, you have several travel time routes set up, and like I said, we had 24 different routes set up in that traffic view tool for many of our major arterials and some of our service road, the freeway service road corridors. Then basically need an user ID for that traffic view tool from Waze. We requested that to Waze, and within a day we get that information. And after that, it basically set up that travel time polar application configuration file, implement that user ID that we get from Waze, and then set up the alert threshold, then set up through the email alert process, that which email system you want to use. There are a couple of options there that I'm pretty sure Ryan will go through in more detail after my presentation. And then the program was set up through a Windows task scheduler on a workstation, and we just started pulling data every 5 minutes with the application running. And then Brian also shared a different program, which is a Waze travel time processor, which allowed us to process the travel time data afterwards so that we can get a good summarized data format. So I'll show some screen on that part as well. The data itself size is very small. We have been using for several months of storing data, but the database size is really relatively small. So it doesn't really require tons of storage with our 24 routes that we had. And then, so that was another nice thing that we really have to worry about. So this kind of a screenshot, that's some of the travel time routes that is on the left side with the map, kind of showing some of the travel time routes that we have set up in the Waze travel time traffic view tool. And on the right side is the screenshot of the second program that Ryan kind of provided to us to process our collected data from the Waze travel time polar. And then it basically lists all the routes that we have over there. And this is after the processing data, it kind of gives that data outlook over there on the top right picture. It doesn't create, at that time when we get the travel time processor application, it didn't create the chart automatically, but it tabulated the data by days, and it creates separate sheets for weekday and weekend data, so which is a nice thing to have. And the travel time processor allows to choose your bin interval, like if you want 15-minute bin interval data processing or 1 hour interval. So you had that option that how many pulse days you want and what bill interval of travel time processing you want, and at that point it basically creates that spreadsheet, and from that spreadsheet just creating those charts is really easy to do. And then another nice thing is that the email alert that it can send, so you can basically set a threshold as a percentage of your average travel time, and then as it reaches the threshold, it sends alert as a congestion summary, and then it will identify the route that that is congested, and it will give the current travel time and the historic travel times, and with the timestamp. So it's very, very useful to have, and it's very easy to see that where you're having issue with the congestion. So we started using that application on different types of projects. So definitely, day-to-day travel time monitoring and reporting. We also use it before and after study. We had a couple of in-house timing projects going on for the city, and as we implement the timing, we have been able to kind of compare the travel times before and after with that historic data be able to store. So which is a nice thing. It also, with that congestion summary, have been able to detect congestion level, and that eventually kind of detects incident condition a lot of time on the freeway service roads. So we have been able to use that for that detection and congestion management. So with that application, we did signal timing update projects, supported 3 different in-house signal timing projects for before after study. We also had incident signal timing plan deployment project, and we had 2 different freeway service roads where signal timing developed for incident condition, and we had a planned some travel time device deployment for that congestion detection, so that we know when to deploy the incident timing plan. So this program actually allowed us to reallocate some of the budget to actually enhance the wrong way detection system on the freeway service road one-way direction, and so that some of the locations we feel like we can really use this program rather than adding more travel time devices, and we can have wrong way detection. So which is a great help in that regard. So that was kind of the story of the city of Irving with this crowdsourced data application deployment, and now I am with city of Arlington. So I want to give you a little bit background of city of Arlington. Arlington is the 3rd largest city in the Dallas-Fort Worth metroplex. This is also kind of situated a little bit south of Irving, but in between Dallas and Fort Worth. So it's kind of similar situation that gets a lot of commute traffic as well. And in addition, city of Arlington is home of University of Texas at Arlington. We have the Dallas Cowboys Stadium, which gets huge events, and also Texas Rangers Stadiums that host about 80 events per year. Arlington is about 100 square mile, population over 400,000, and as you understand that Arlington is bigger city than Irving. They have 364 signal, 175 monitoring cameras. Arlington's communication infrastructure is built on fiber, so there is fiber communication throughout the city, and a lot of ITS devices are connected through the fiber communication. City of Irving has a long history with the Waze Partnership. They are actually partner with the city of with Waze since 2017 January. So and then because they have so many events, we have so many events in the Cowboys Stadium, Rangers Stadium, construction, etc. So there are many roadway closures, and all those data are shared through the Waze. City even developed a in-house kind of web application for events, so that for majority of the events are loaded in their road closures in that application and just sends to the Waze through a data feed. We have a geo-event server that kind of also records the Waze data feed, which gives most of the closer information, some congestion information as well, but it doesn't record the travel time actually from the travel view tool. I know that Waze recently may have developed a travel time data feed, but that was not in the geo-event server. And I have a plan to definitely move forward with this travel time storing our historic data storing in our geo-event server, either through this Lake County Waze travel time program. So this is kind of the project that I'm kind of talking to our IT department and GS analyst and our traffic engineers that want to move forward in this direction as well. So that was my presentation, and this is my contact. So if anyone interested to contact me, please feel free to send me email or call me, and then yeah, we can definitely discuss. And I know there will be a question and answer session after Ryan's presentation, so I'm available for that too.
Thanks, Monsur. And it's kind of interesting. You're just like the Dallas Cowboys, who were once in the city of Irving and then ended up in Arlington. So appreciate your presentation. So you're following them. And from what I understand, also AT&T Stadium also has a traffic management center, and so find that interesting as well. And probably for another time, we may want to learn a little bit more about that. But our next speaker is going to be Ryan Legare. And Kevin, if you could set up Ryan's presentation, I'll turn it over to Ryan. And again, we'll take questions at the end of Ryan's presentation. So feel free to start populating the question and answer chat box with your questions. And we'll coordinate them as well from the beginning of the question and answer session. Ryan, all yours.
Hey, everyone. I'm assuming you guys can hear me okay?
Perfect.
Excellent. Okay. I know there was some questions about audio in the chat, so I just wanted to make sure you guys can hear me okay. Okay, so good afternoon or good morning. I'm going to talk a little bit. I'm going to give you guys a little presentation on what crowdsourcing means to us and what that is to us, and then talk a little bit about the Waze Travel Time Polar program that Monsur just mentioned. And then I'm going to actually give you guys a little bit of a demonstration. I want to kind of stress that it is pretty easy to use. It should be a fairly low learning curve, and I think it's applicable to everyone. I think you guys can download it and start using it today. So I want to kind of show you guys how easy it is. So I'll walk through the presentation first. So good afternoon, and thank you for having me. My name is Ryan Legare. I am the TMC Manager at the Lake County Division of Transportation and have been here for about 13 years. The biggest thing we've noticed over the last few years is how helpful crowdsourced data is, and moreover, how much we're actually using it. We went from using all police CAD, computer-aided dispatch, traffic signal data, count data, to now we use crowdsourced data in every analysis and decision we make. I think it's more powerful than I anticipated, but it makes sense. You're using real granular data, which is essentially live. I'm not an engineer, but I handle a lot of our data, and the one thing that was always frustrating was how limited or boxed in our data is. You can get count data or congestion data at the signals, but it's limited to where detection is. We can get incident data, but it's limited to how many police departments we're connected to, which are not all of them. So crowdsourced data has really become a part of our everyday lives, and it's changing the way engineers make decisions. Crowdsourcing plays two major roles for us: supplementing our computer-aided dispatch information from the police departments, which gives us better roadway information about incidents, and also it helps us gather travel time data for traffic flow analysis, like Monsur mentioned, and I will be going into a little bit more as we go on. So Waze was able to help us solve both of those problems. So a little background on Lake County, Illinois. Lake County is the northeasternmost county in Illinois. We have about 700,000 people live in Lake County with a traveling public about 2 million daily. As I know that's gone down obviously since COVID, but about 2 million people travel through Lake County a day. If you guys have been in the northeast part of Illinois, that's where Six Flags is. Six Flags Great Americas in Gurnee. So that's one of the things in Lake County. We have about 750 traffic signals in total of Lake County. That includes state, county, and local traffic signals. About 640 of them are connected to our central signal system. We have about 415 PTZs that is connected using about 300 miles of fiber, and we have direct connections to both IDOT and the Illinois Tollway. Our ITS system is called Lake County Passage, and that was started in about 2004, and we've grown since then. So the Lake County Passage system, we have two main parts of what it is, but one of the main parts is travel guidance. So we get information in from various sources, computer-aided dispatch from the police department, Waze event information. We work closely with construction engineers, and we take all that information in, gather it, and we put that out on our Passage system. And our Passage system consists of a highway advisory radio station, 1620 AM. We have email notification. We have a website, lakecountypassage.com. We have smartphone apps. We also have Twitter, and we have portable changeable message signs that we put information out on as well. So we try to get information out as much as we can to the motoring public. We are also tied in with Waze, and we know that Google and Apple use our information as well. So this is, excuse me, hold on one second. This is our TMC Manager, TMC Management Center. TMC, we're open Monday through Friday from 6 a.m. to 7 p.m. We have two operators that cover that time period, one in the AM shift and one in the PM shift. And then we have some offices on the back side of this picture where our engineers sit, and our engineers, including myself, the manager, are able to help out the TMC staff whenever needed. And we do work outside those hours if necessary. So recently there was actually this past weekend, there was an air show in Waukegan, and myself and one of the engineers helped work that and change some traffic signal timing to some signals around Lake County during that. So in talking about our Waze partnership, after trying countless different methods to collect more data, we found that we were still limited to our hardware infrastructure. For example, for travel times, we could put out Bluetooth sensors, but they were limited to our traffic signal installations. We also found the data to be very unreliable on arterial systems with a hit count below about 5%. We tried other software for collecting travel time data, and we found it very costly. So what were the alternatives? Around the same time, we started very closely looking at using probe data to help us in traffic analysis. We tried Google Traffic, which is similar to Waze, but it had a very high cost with that. So around that same time, we had heard that there was another agency that was using Waze for their event and travel time information. So looking into it a little bit further, we found that they had a data sharing program for public agencies. Now, I know most of you guys know all this information. I'm just giving you a little bit of background for us going back a few years now. So as quickly as we could, we joined the Waze Connected Citizens program, which was the name at the time. Now it's Waze for Cities, with the original intent of giving and receiving incident and event data. So we had good information that we knew that we had from the police departments, and we could give that information out to Waze. And we also knew that we had good roadwork information from our construction engineers. That would be something that Waze would be interested in. And in return, we would want the user data for knowing about crashes and incidents on Lake County roads, especially in areas where we didn't have good coverage from the police departments. So for us, it was a win-win. But after we initialized the contract, after we went through integrating, we actually found out that there was some more information we could get from that, and that was the travel time data that Monsur was talking about. There's a tool that Waze offers we found by doing a little bit of digging, you could actually get the travel time information from that website. So we started receiving incidents from Waze, which was helpful for our TMC operations, but we also started relying very heavily on our Waze travel times as we found how useful the data was. One of our signal engineers started building a bunch of travel time routes that are key for us, and I started building a program that could parse, archive, and alert us for heavy congestion. As a result, we now have over 600 travel time routes, and we have a poller that we built that actively polls those routes, archives all that travel time data for future use or analysis, and alerts the operators if and when any route is considered congested by our calculations. So we've been collecting this data since about 2017, and we've seen that it's proven very useful in comparing traffic during COVID-19 and other times. So the Waze travel time poller that Monsur mentioned, that is something that I started work on, knowing that it would allow us to collect this travel time data from their website, which we could use in real-time monitoring, but also to archive data for analysis and trends. So as Monsur mentioned, it's been very helpful for us. We decided to open source it to GitHub, and we've seen some popularity from other agencies downloading and using the program. And I'll demonstrate that a little bit later, the program, as I mentioned. I've also been in contact with Waze. They have reached out to us and asked us if we would do a write-up on the program so they could make it one of their quote-unquote unofficial programs that they will recommend for other users to kind of keep travel time information. So from there, we integrated all the Waze travel time ATMS. So we do have an ATMS. We integrated both the event data from Waze and the travel time information into our ATMS. And it's helpful for the operators. We get notified of any congested segments, congested routes, and we can take all that information in, gather it, and then push that out to the traveling public. And we found that to be very, very useful. Talking a little bit more about the TMC operations, now that we had it integrated into our ATMS, like I said, we could see the Waze data along with the CAD data, and we found a few things that was kind of interesting. Waze was allowed us to kind of confirm some iffy information we have from other sources. So if we weren't sure about a crash, we'd start getting a bunch of incident information in from the Waze events that kind of helped us confirm there were things going on. And then one thing we also noticed is that Waze incidents kind of came up quicker than police calls sometimes, which I think is kind of funny. People would report it on their Waze app before they would even call the police. So it's kind of an interesting conundrum the world is facing right now. Just kind of thought that was an interesting anecdote. So one of our engineers then, they put together this information you can see here, and it was essentially some ideas on how much we were actually using Waze and Waze events for us. And you can see that during this week in early 2020, we determined that 1 out of every 10 events that we were confirming was a Waze event. And you can see a breakdown of some of the information there. So it is a very helpful supplemental system for us. So after we integrated it with our ATMS, we also integrated it with our newly acquired ATSPM software. So TrapOp, which is now owned by MyoVision, they took and integrated the Waze travel times into their SPM system, which would allow engineers then to compare traffic signal information along with travel times. So they could see kind of the delay rising with the traffic signals and also the Waze travel times rising, and they could kind of make some determinations on traffic signal timing changes they need to make along corridors at a particular signal. And they found that the information to be very, very helpful when making those determinations. And they can go back and look at and see, once they've made some adjustments, how much did it actually improve traffic signal timing coordination. So moving forward, we took travel time information and we decided to apply that to project selection. I'm not an engineer, but our engineers, I'm told, like this because they can take this Waze travel time information, some averaged information, apply it to projects and say, you know, here's one that may rise to the top because we're noticing some unusual congestion in the area, or we can see the congestion has risen, you know, sharply over the last few years. So we do use that in our project selection, and that's something the engineers like using. And then a few more slides here. I'll talk about future construction, the future of Waze travel times and how we're going to use it. So one of the things that our engineers were looking at was, if we have a construction project, how can we use Waze travel times to do travel time route information, similar to how the tollway will do it or the interstate would do it. Now, an arterial system, that can be a little more difficult, but we found if we can put our changeable message boards on some of these alternate routes, or at the starting point, we can tell users that if you're going to travel this route, you know, if you go straight through the construction project, it's going to be heavier, but if you try these different routes, it's going to be lighter. And that's something that we've started to look at and something we're hoping to use moving forward. But we think this is going to be a nice, useful tool. This is a little bit of a flow chart on how we'll determine how to use that, how we'll determine what routes to put out on the message boards and stuff like that. So, all right. And then one last thing we're doing for the future is that we're looking in this concept of weather responsive. So we know we have the Waze travel all the time. It's about the travel to versus time. And you obviously things are trending. So we found that during a major weather event, snow event, heavy rain, things like that, we can see the travel times creep up, pretty much on a level. And so one of our engineers had the concept of, if we can take that travel time information and know that it's increasing delay along a corridor, we could theoretically change splits and offsets to accommodate the coordination along that corridor. Obviously, if there's snow and people are going 30 miles an hour instead of 45, the progression is going to change. So how can we adjust on a system level that progression using the Waze travel time information? So this is something that we're looking at. It's kind of higher concept, next level type stuff, but we're interested in looking at this and using it a little bit more. So now I'm going to show you guys a little bit about the Waze travel time program and how open source can help you. So I'm going to share my screen here. You guys can see my monitor, I assume. You see GitHub Waze travel time poller?
Yes, that is correct, Ryan.
Yes, we see it.
Okay, great. Okay, so what I want to show you guys is this is the Waze travel time poller. This is what we created in-house and then put out on the web for open source. And open source essentially means you guys can go download it, you can use it free of charge, and it's minimal effort, and that's what I'm going to show you guys a little bit. So I included some instructions here on how to use the program. It should be fairly straightforward. I also included some links and some instructions on how to do this. Now, when Monsur did it, these instructions didn't exist, so it was a little more difficult for him. But I included all this information here for you guys to use, and then also my contact information is here as well. If you'd like to reach out, I can help you out. So one of the pieces of information to help is this instruction pamphlet that Waze themselves provide. So this is the Waze Traffic Tool and Feed Boot Camp. This was a webinar that they provided. I took the PDF documentation and included it in the docs folder of this project. So when you click on it, there's a PDF that will kind of walk you through each step of at least getting the information from Waze. That's the first part of the challenge. So I'm going to walk you through what that looks like right now, and then I'll show you how to actually get the information. So the first step is they want you to sign up for Waze for Cities. And so you can sign up for Waze for Cities using this link here if you guys are not already. It is free. It will take a couple of days to confirm your connection with them. But once you get it, you will then have a partner dashboard. The partner dashboard looks like this. So there's some different information along the side here. But once you get to the partner portal, you'll see some different things that look like this. And this is all in the instructions here for you guys. So the first thing you're going to want to do is request the Waze travel time tool. So that's our traffic view tool. That's this one here. And again, that is number 2 here. Request access to the Waze traffic view tool to the partner dashboard. So what you'll do is you'll request here. It'll ask you the parameters or locations of the information that you're wanting to, or your area that you're wanting to get information from. You submit all that information, and actually it kind of shows you in here. It'll kind of show you some different information here. You submit that, and then they'll give you access to that. When they give you access to that, you will have access to this page now, which is the Waze.com/traffic view. And so this is something that they provide you, and they'll provide a lot of media. So like a lot of news channels will have access to this. And if you're okay just with using this website, this will tell you all the information you need to know. This is all real-time live information as of what's happening on the system right now. But our program takes it a little step further and grabs the information from behind the scenes. So once you sign up for Waze Traffic View Tool, you'll come to this website and you'll start adding travel time routes. It's as simple as adding the plus here. You'll zoom in on a part of the map that you're interested in. So you can you'll click the first route. Then they want you to select the second part of the route, which will be here, and it will load. You can see it load that route, and then it'll calculate it, and then you will hit save, and now that becomes a new route in your list here. Okay, and so you can do that as many times as you want. I told you that we have about 600 of those travel time links. I think they allow about 200 per feed. So you can see here we have a few requested. They allow about 200 per feed. And when you're in this, you can see the drop down here. It gives you the ability to kind of go between some different ones. So you can see this one has quite a bit of information here. Okay, so that's going to be the second part, is actually getting the traffic view tool. So the next part is getting the Waze traffic view feed. Now the feed is what really is behind the tool. And again, there's some instructions on that through here. Request a traffic view feed. You're going to come in here, request the traffic view feed. You request it within 24 hours. You will get a response. It was accepted, and it will show up like this in here and tell you you have this link here, this data JSON link. Okay. So when you click on that, you're essentially going to see this, which means nothing to most of you, right? So that's not very helpful at this point. But this is the information that the travel time poller needs to be able to start archiving travel times and kind of reporting to you on how traffic is moving. Now, the important thing for the program that we created is that you need the unique user ID. So when you click on this link and it opens up this window, you can grab the ID one of two ways. Either you can grab it here, so it's this unique ID right here, or if you search in here under the broadcaster ID, you can grab it from here as well. This is the piece of information you need for our program, okay? So if I grab this, and I'll just kind of put it off to the side here, and I'll keep that for now, all right? So once you have all that information, now you can start using our program. And I'm actually going to give you guys a walkthrough demonstration, and I've tested this a few times, so hopefully it works for us. Are we doing okay on time here?
You're doing fine, Ryan.
Great. Okay. All right, so I went to the GitHub page back where we started, and over here on the side you'll see releases, okay? And there's a few releases. If you click here, you'll see there should be kind of a history of the releases here, but the latest one is version ..4. So we're going to click the zip file here. If you're using Linux, it's going to be a little bit different, but if you're using Linux, I trust you know what you're doing because it takes a little bit more of a learning curve. So we're going to be talking about only Windows for now. So we're going to download this program, this zip file, and we're going to save it. And then we're going to go to our downloads folder, and you can see it downloaded the zip file. It's only about 8 megs, so it's not very big. And then you're going to unzip it into the location here. And so now we have this Waze Travel Time Poller folder, okay? Now this is where the program resides. Now you can take this folder and put it anywhere you want. You can put it on your desktop, on a shared network drive, anywhere you want you can put this folder. but the key is to make sure that you keep everything inside the folder where it belongs. That's really important, is that you keep all this stuff where it is right now. Okay, so we're back to our Waze travel time poller, and the thing that's the most important is making sure we give this program that feed number. So we're going to go into the configs folder. We're going to go to the config INI. We're going to open that up with a notepad or any notepad you have, anything that opens up an INI file, and you'll see something like this. Now this is the config file, and in your own time you can feel free to read through all the comments and what each one of these things mean, but I will go just over them briefly. So this basically tells you that this is the name of the database you'll be using. The database is actually included in that folder, so you don't even have to worry about that. Congestion percent. This is how much above the historical travel time do you want to consider something congested. So 100% would be, if it's 5 minutes on this route and the current and historical are 5 minutes, that would be 100%. But 175% then would be, I don't know, 8 minutes, let's say. So we say this is 175% above the historical value. And then this tells you, this congestion summary poll just says, alert us every 5 times you run this program if there's a congested alert. Again, you can read all this stuff through the comments here. There's some information about triggering an error, and then there's also the ability to set up email notifications. So you can use, we use Google, and I think Monsur does as well. So we use Gmail. You can use Gmail login credentials here. You can set up the emails that you want to be notified to. So this would have like my email here. And then this here allows you to use something, the program uses SQLite, which is just a database file. But if you want to use something like a PostgreSQL database or a Microsoft SQL database, you would put some information in here, and I can help you kind of get started with that. And then down in here, there's some things about skipping and omitting routes based on if they're having issues or erroring out. But the absolute most important thing for you guys is you can leave all of the rest of this stuff alone. The most important thing for you is to put in the Waze UID in this section here. So I'm going to go back to where I grabbed the Waze UID. I'm going to take that. I'm going to paste it into this section here, and that's it. You don't have to change anything else, okay? Once you have that in there, it's ready to run. Come back to this page, and you can either run the polar exe or you can use the run.bat. Now, for our sake, I'm going to use the run.bat, and you'll see this. And this is essentially some log information about what it did. But it found that feed. It took all the information in it. It wrote it to a database and went on from there. So as of right now, you have successfully run the Waze Travel Time Polar program. Now, something I should mention, it does not require administrative privileges. It does not require downloading any other software. It does not require a SQL database outside of this. It is completely self-contained, and so you can use this outside of permission from your IT department, although I wouldn't suggest that. But you're allowed to use this. You could use this on a desktop. You could use it on a server. You can use it anywhere you want because it is self-contained with all the code and the database and everything. So once we ran it, which we did, and all that information on running it is in here. So now what do we do with the data? How do we get the data? How do we find it? What do we do with it? So a little bit lower, I included this here. This is a program I did not create that allows you to browse your data. It is a free program. Again, no administration required. You can use it just on your own. You download this program, and it is another self-contained program here, DB browser for SQLite. When you open this, it'll look like this. You can go to Open Database, and then now you're looking for, again, the Waze Travel Time Polar folder. You're going to go to the database, and then you're going to click Waze Travel Time DB. And so when you open this, now you'll see this, which allows you to then browse the data. And so when I click Browse Data, now you've got the information we just downloaded. You can see your routes here. You can see the travel times for those routes. And now you can access this data anytime you want, and it's all right here for you. You can see here a couple of things. Current travel time comes in seconds, but I translate that into minutes for you, so you can see the minutes here. The congested percent, so it'll tell you what the congestion percent was at the time it ran. It'll tell you also, was it considered congested? So if you run this for 10 days and come back and look at the data, you'll be able to see, hey, this was a few congested segments. Maybe I should look into those a little bit more. And then you can see the timestamp here. So if I go back to the folder and run it again, it will go through, do its thing. And now the data, again, is inside of here. I just hit refresh, and now the new data is in this, in the database. And so you can keep doing this as much as you want, as long as you want. I will say there's a few caveats. Supposedly, this database can grow to like some insane size. I would suggest not doing that. I would say if this database got big enough, you could copy it off somewhere and just make an exact copy of this one and just keep writing to this. So I'm talking like 200 gig or something like that. You might start seeing it slow down a little bit. But again, all of it's self-contained. It's all within here. It was simple. All you do is put in that, you put in the UID, and you come back and you run it, and it runs. Now, I will also add that if you add more routes, the routes will be brought into here. If you delete routes, it will know that that route is no longer available and it is deleted. So you can keep adding routes, subtracting routes as you go anytime you want. And then, you know, obviously you can keep adding data. So all of that information and the instructions and everything are written into this page. One thing I will note, and Monsur mentioned it, is that you can use, Windows has a task scheduler, which is simple, so you can make the task scheduler run the program, but it is limited to 5 minutes. Waze updates their information every 2 minutes, and Windows Task Scheduler is limited to every 5 minutes. So I have a task to come in and actually update our program, which will allow you to run it without Windows Task Scheduler. You just basically run it, and then every 2 minutes it goes out on its own to grab all the information. So again, pretty simple, all self-contained. You can use the information, and you can start using it right away. And all the information is here. If you want to look at a route, you say, I got this route here, 16913. You can come into here, 16913, and there's the past 2 times it ran. A few more things. When you run it, if you run it once, obviously this data is updated, so it'll insert the information. But if I run the program again, because Waze has not updated their data, it is not updating the travel time. So it will only insert a travel time once. It will not insert the same one twice. So there's a couple catches there, which are very nice. All right, and then one last thing, I know we're getting short on time, is I wanted to show you guys the next step of what we're doing, and kind of Monsur talked about it. So what do you do with this data then? How is it useful for you? We created another program, which I will soon open source, but it allows you to actually take the data and look at it a little bit nicer. So you would open this program. Again, I'm going to open source this and I can send you guys links, or I'll add a link to the GitHub page. But you open this program, again, self-sustained. It will look directly at that database, and then you can pull some information from it. So we'll say I want, starting September 5th, I want 7 days of data. I want you to give me the data in 60-minute bin intervals. You can change that to whatever you want. And then I want you to include a graph. It says it's not supported yet, but it'll work for what we're doing. And then I'm going to choose my route. So the particular one I'm interested in is this route here. So I have all this loaded up. I hit run. It'll go through its little run period here. Give it a second. Well, this puts out some information for you to use. Number one, it provides a graph. So you can see here that this travel time at some point was having some congested issues. Likewise, there's another one here. You can see on the 9th, there was this heavy amount of traffic between 7 and 8 o'clock. It's pretty easy to see that. You can see most days in the afternoon, they're kind of all about the same. But you can see this pretty much on your own. But the other nice part about the program is once it's done, it's running, it will output some Excel files for you. The Excel file, and this is what Monsur likes using, will actually summarize that data for you in those 60-minute bin or intervals. And you can see here there's one tab for weekday and there's one tab for weekend. And here is where you can see kind of that congested level area. You can see that, here is the travel times through the day. Here it is here. And you can see right here is where we saw that kind of bubble on that graph. So all of, basically taking the data, kind of averaging and summarizing it into this file here gives you even more tools on how to see how the data is working and how it's working for you. So start with the travel time polar. You guys can download it for free. Do anything, start downloading stuff today. And like I said, run it as much as you want. It'll start grabbing all the data. And then shortly, I will have this open sourced, and you guys can start actually using the data and using the tool for engineering analysis. So I know I went fast. I apologize. I know I spoke a lot. Hopefully it wasn't too much. But that is the extent of my presentation.
Hey, Ryan, you're spot on. We appreciate the tutorial that you just shared with everyone. It was well worth it, even if you went a little bit longer than planned. But and no wonder why Monsur saw a lot of uses in your open source Waze travel time polar. That's become very helpful. And this is one of the reasons why our Everyday Counts program, Advancing Crowdsourcing for Operations, made it from round 5 of Everyday Counts to round 6. And that was because we saw a lot of our municipalities, state DOTs start applying a lot of the different uses of crowdsourced data. In this case, they use the open source platforms that kind of help encourage and meet some of the needs that they are using to not only promote, reduce delay on their arterial networks, but also be more efficient and eventually respond to incidents a whole lot quicker, which could also save lives as well. Again, remember, by being part of the National Operations Center of Excellence, our Adventures of Crowdsourcing series is being recorded. So I'm sure many of you on this call today can kind of come back to and kind of sit down and pause Ryan's presentation and learn a little bit more on how to kind of use his processes to kind of help with your own systems as well. Right now we want to go into questions and answer, but before that, and I don't know if Ben Pichot from our contractor who's with AEM, if he's joined, but we do have Chris Lambert. And Chris Lambert is with the Kentucky Transportation Cabinet, and he's also on our national Everyday Counts Adventures in Advancing Crowdsourcing for Operations national team. And Chris, I want you to kind of share some of your thoughts, especially from a state DOT level, on some of these applications, whether or not if you used any open source platforms to kind of help support your efforts.
Sure. Thanks, Ralph. Yeah, this is Chris. So our entire stack was open source when we got started. We started in 2014. Signed with Waze and started trying to look at that data and how we could implement that with snow and ice and real-time operations. Then by 2015, we were starting to look at products like Hadoop and Kafka and Elasticsearch and things. So some of the issues that we had, number one was open source wasn't approved as any type of a legitimate platform or product for us. So open source software was kind of a no-go on the IT front. So, but with it being open source, one thing you can do is you can actually download the products and you can give them a try. And that's what we did. We actually, we had a gentleman that understood Hadoop, so he downloaded Hadoop, put it on about 2 or 3 computers so it would distribute, and then we just kind of experimented with that. We used Spark, Apache Spark for real-time processing, and later used Kafka for IoT aggregation and things. So that's one issue is you want to make sure that your IT department will approve open source software because at the time we were a C# and SQL Server shop. We nothing else is approved to use. we also, we used the free versions for proof of concepts. Matter of fact, right now we're migrating onto Google Cloud, and our virtual machines, our VMs, we still have a cluster of VMs running Elasticsearch, and that version is the free tier. Now, Elasticsearch just changed their licensing. That's something else to be aware of. It was free and open source. Now it's just free. They've gone to closed source, but they do keep a free tier for agencies, and there's no restrictions on that, but it does not come with any support. So in our case, we did go with open source software, but we did pay for support contracts. Those support contracts are relatively cheap. We went with, Cloudera for Hadoop and Kafka and Spark, and that was about $50,000 a year. And then Elasticsearch is about $50,000 a year also. And we made some use out of that. And then there's other things that we're just now starting to look at. We have moved to Google Cloud, and one of the things with Google Cloud is they use a lot of open source technologies or underlying technologies. So if you're already familiar with open source and you go to their cloud, everything migrates really well. We're also looking at stuff like e-charts, like Apache e-charts for dashboarding and things to maybe supplement or even take the place of Elasticsearch is their Kibana, which I'm a huge fan of. I love Kibana, but it doesn't dig back into Google BigQuery, and we're looking for something there that we can, some type of open source license dashboarding product that we can use. So we're utilizing some of that as well. Now, as far as putting our code on GitHub, one comment that I'll have there is that we went through the pain of trying to get that through our IT department, and they ended up, after a little bit of back and forth, they ended up approving it, saying, okay, that's fine, but then it went to legal. And when it got to legal, it just stopped because all of our work, even our code, is subject to open records request. And when you open a professional GitHub account, they have you declare a license, like an MIT or GPL license. And so our lawyers simply said, well, we can't license what's already free and subject to open records request. So it kind of got stuck up in our legal department. So we were never able to actually publish any of our code to GitHub. But again, we do make that available to anyone, any state that just wants to email me and ask for the code. We'll gladly do that for you. And then anybody from the public. When I was a private citizen there for a little while, I left the cabinet, retired for about a year, and I actually requested some of our code. And sure enough, they gave it to me. So we usually try to fulfill those requests within about 48 hours. So those are some of the complications you may come across with your IT department, your legal department. IT, of course, is going to want to clean up the code, and then they're not going to want to maintain two repositories, one on GitHub and then one internal. So there are some hoops you need to jump through. But yeah, we've made a lot of use out of open source products and open source code from other agencies. And then, like I said, we do share that out based on open records requests. We just don't publish those to GitHub. So anyway, those are the few issues that we've come across in our agency. And so just be aware of those things when you start getting into open source software or trying to share code on a platform like GitHub. That's all I would have to add.
Thanks, Chris. If there's anybody with questions for Chris, also feel free to add them into the chat pod. So, Chris, thanks a lot for adding some of the insights and some of the administrative issues that are centered around with open source uses. But again, it's probably something that you want to check first within your own agency and see how that all fits together. We got a few questions. I don't know, Grady Carrick's on the line. If Grady, you want to handle some of these questions, I think some may have been already answered. But
yeah, Ralph, we can go through the chat pod, I think, and just pull these up, and then our presenters and feel free to jump in. I know the first one is tagged for Monsur, but certainly anyone can answer. But I was talking about the tech stack, and is it cloud hosted, and what program does it use? Is that something that you'd like to handle, Monsur?
Sure. I mean, I believe I got the answer that it's basically the Waze data basically comes from the cloud, but as the program itself, the traffic program, as Ryan mentioned, it itself sits in a desktop or in a server or however you want to put it, and it runs on a scheduled basis. So, and the database is stored in a physical place, and from that you do the process the data.
I'll just add that it is not. I'll just add that it's not cloud hosted. It is using Python. As you saw on the GitHub page, it's 99% Python code. Two things. One, something that Chris mentioned, but also to answer this question. So the code itself is available as open source code, so you can see it and you can go through it yourself there. But when you download the Windows or the zip file, it actually does not include the code as a readable code. All of that is actually, all the code itself is actually wrapped up into that exe file there. So it is no longer, I mean, it's not, the download doesn't come with all the source code kind of viewable and stuff. So, but it is all written in Python, and it's all turning new and executable for Windows. But if you're going to run it on Linux, it's just Python, and you just use download Python and just run it from the code there itself. So.
Okay, excellent. Thanks for adding on
Ryan.
to that. Yeah, Ryan. Pete Vega was asking about validating the accuracy of the data, and he was wanting to know if probe vehicles or there was any data quality analysis employed.
I'll answer this. So we tried a bunch of different things. We tried Wi-Fi readers, we tried Bluetooth readers, we tried Google Travel Times, and we finally settled on Waze Travel Time because of its availability and accuracy. So when we found that all the other platforms, I mean, Google Traffic, obviously, Google Travel Times was accurate, but just very expensive. But when we used Bluetooth and Wi-Fi, it wasn't accurate enough. We didn't specifically compare it against probe vehicles, but what we did find is that comparing it against Google, comparing it against Apple, comparing it against our real-time detection at our traffic signals, all of that combined was able to tell us the accuracy of the data itself, that it was actually, as it congested, time went up, and you could see it actually, going up and then coming back down. So we didn't very specifically vet it with like a probe vehicle, although I think our summer helpers might have done a little bit of travel times on a few routes where they actually started at one end and timed themselves to the end, and we may have kind of done a little bit of that to try to validate some of the data. But we just found it very accurate from the start with both the historical and the current data. Pete's saying there's about 20% error rate along arterial roads. So we haven't, I don't know if we have anything, that scientific about the actual error rate. We have found it to be very accurate along arterial roadways. So Pete, we will maybe look into that a little bit more.
I'll just add that in some of our arterials, we actually use probe vehicles to kind of gauge the travel time on those corridors, and then compared it with the cloud Waze data when we are doing the real-time analysis, travel time analysis, and then it's with that amount of traffic and everything we had, I think the data accuracy was very reasonable to be able to use the crowdsourced data.
Okay, excellent. Excellent, and thanks for that follow-up question, Pete. I think that helped with the explanation, the answer there. And I want to also recognize Russell Holt for chiming in the chat and offering some experience that he had as well. Yadola is asking about how travel time and incident information tie into signal timing changes, and I'll just open that up to the panel.
I'll take that since I mentioned in my slide that we had a couple of projects with signal timing and incident. So the travel time, if we do signal timing for a corridor targeting that platoon progression, then travel time is a very important factor of measure. So there are a couple of corridors that we are doing is actually for platoon progression for a certain commute traffic. At that point that we have been able to compare the before and after travel time, what was the platoon progression change, how much travel time we have been able to save after the signal timing was implementation. And on the incident side, which is important factor as well, when incident happens on a corridor or on a freeway, if it's a major arterial or it's a freeway, in that case, I will start with the freeway, that a lot of traffic gets diverted on the off-ramp and get to the service road parallel to the freeway, and those corridors started getting heavy and their congestion level started increasing. And at that point, if we know and get the alert, hey, your travel time on those corridors are increasing, and you know that you are getting a lot of additional volumes in that case, and with the incident timing plan having available and be able to deploy that at that time, is actually serves those additional traffic, and it actually itself release some pressure where the incident happened because the diverted traffic moves quickly, as well as it serves those diverted traffic, and their travel time actually, it increases definitely when you're in congested condition and you're getting out of freeway on a city arterial corridor, but it still be able to move those traffic.
Okay, excellent. Thank you, Monsur. Brian Mullen is wanting to know about the data, and could you use it with something like Power BI to do some analysis and dashboarding?
I have not, we have not used Power BI, but you could. I don't know if Power BI ties into SQLite. I actually don't know how that works. Right now, like I said, it's using a SQLite database, which is just basically a file, not actually a database server. SQLite is very widely used, so you can. That's why it's easy to use. It's open source. It's free. It's things like that. So that's where we're using SQLite. So I don't know if Power BI will tie into it, but we actually run our travel time system on Postgres, which is an actual server like Microsoft SQL Server. And Power BI most certainly could tie into an actual SQL server. So if you want to take this program and actually spin it up on a SQL server and your IT approves it, let me know and I can help you get that started.
Excellent. Thank you. Kruti is asking about Passage and I guess how it works in terms of making the data somewhat readable. Is that essentially what Passage is doing?
No, so Passage is our ITS system. It's just everything together. Passage is our ATMS, our cameras, our smartphone apps, website, all that stuff. Passage is our ITS system and public-facing side of our TMC. That is our program. I'm a part of that. I'm a TMC manager, and I helped create the program, or I created the Waze travel time polar. But yeah, the polar itself is what takes the travel time or the travel time information from Waze and quote unquote turns it into readable data for us, the engineers. We don't actually publish that data. And if I'm not mistaken, we will publish, be careful what I say here. We can't turn around and publish the data the same way Waze does. They don't like that. They don't want you doing that. So I can't take this information and turn it right back around. You're allowed to come up with some congestion alerting information on your own stuff coming from the Waze travel time feeds. But yeah, this tool itself is to take the data and basically allow you to archive it and analyze it later on.
This is Chris. I can jump in and explain the Waze republishing thing. This is from KYTC's point of view. We found, I don't know if you call it a loophole or just a method of doing this. Same thing. You're not allowed to republish the data directly, but what you can do, and what we got permission to do was we created a derivative of their data using our linear referencing system. So like KYTC, like road name, KYTC route ID and all that stuff. And then we just added in, of course, the important information from them, which is like the delay and the speed. And they were okay with that. They were okay with that attribution as long as we didn't reveal their entire schema to the public. So that did work. We just grabbed our roadway information and published their data, I guess, if you will, with our stuff. That they're okay with that.
We do something very, very similar, and thank you for saying that. We have found that Waze themselves have been fairly easy to work with. I believe they're one of their terms of condition when you sign the agreement. I believe they say that you should not store their data, which is obviously counter to what we just have been talking about for 2 hours now. But when we talked to Waze, they said that was fine, totally fine. You can store it, you can use it. You can use it for analysis, and like I mentioned at the beginning, they even said, we like your tool, please send us a write-up so we can use this as one of our unofficial, tools that we recommend. So, kind of like Chris said, that there are workarounds to using the data, and they're very free and open to allowing you to use it.
Okay, let's take
one
final question here, and that's from Nathan, but it's a great dialogue going on.
Yeah, excellent responses there from our panelists. Thank you. Yeah, Nathan came back with a couple more questions, and he's asking about alternate route travel times and if they're stored, and then he has a question about running on a desktop application, and I guess the computer going to sleep. Go ahead.
Yeah, the number one, do you store the alternate route travel times? I'm not really sure what that means, other than like we just will create a bunch of routes and store it all. It's, if we have a route from A to B, we'll also do it from B to A. And then if there's an alternate route, we'll have that, C to D and D to C, so we just have as many routes as we can possibly can and store it all. And then when it comes to running it on a desktop computer, obviously you don't want it to fall asleep. I believe the Windows Task Scheduler has some stuff in it which will allow you to, I don't know if it wakes, but it'll allow you to kind of run the program if it's been in the background or if you're logged out and things like that. So I would look into the task scheduler and see how that goes. We run it on a server, just easier that way because it's always running. But you can play around with it, test it, see what you come up with.
Yeah, no, Ryan, it actually allows you to wake up the computer. So I use that, and it basically keeps running. It doesn't stop.
Oh. And then Nathan asked a follow-up. Nathan, we do not keep the best alternate route. We from the feed, we only take the static routes we programmed. We do not store the alternate routes. That's maybe something we could do. We could add it into the poller, but we do not store the alternate routes as suggested by Waze.
And it looks like
Excellent.
Sharon Kai slipped in one last question here, so we'll take hers too, Grady.
Okay, great.
And
thanks,
that is
Ralph.
The Waze traffic alert.
Yep. And Chris, I think you've got some experience with this. Maybe you can jump on that one. So Sharon is asking, for the Waze traffic alert data, did you set up any rules to filter the JSON feed?
Oh, yes. No, we grab everything. We grab it every 2 minutes. That's kind of a whole other presentation in itself with data management. But we absolutely filter that information. So like on alerts, for crash alerts, for example, they call them accidents in their data feed, major accident, minor accident. We filter based on thumbs up of 1 or greater because we found that about 40% of the records are within a reasonable distance of that another record with a thumbs up of 1 or greater. So it eliminates a lot of static, a lot of noise out of our data. So we do that with crash alerts, and then we compare that with the speed data on the same line segment. And then the speed data we use here, probe data, we use a jam factor of 5. It's 5 out of 10, and that's approximately 50% of free flow. And when those two things are true, then we send an alert to our traffic management center. So you're looking for Waze alerts for the thumbs up of 1 or greater, and then traffic speeds that are at whatever threshold that you think is reasonable, or that you think may be an anomaly in your data. But yeah, we do quite a bit of filtering on the Waze data. Now the jams we don't really filter a lot because we don't see a lot of traffic data from Waze that's outside the norm. Most of our traffic data from Waze is actually about somewhere between 40 to 60% of free flow already. So we just go ahead and preserve all those records.
Excellent, Chris. Thank you so much. Ralph, we're getting close on our time, so I'm going to throw it back to you.
Okay, thanks, Grady. And why don't we go back to the original presentation and just a couple last-minute items that I want to share with all you all on the call here. And before we dismiss, I want to thank our guest speakers, Monsur and Ryan, as well as Chris, for their contribution to today's webinar. I also like to thank the National Operations Center of Excellence for supporting this platform and maintaining our database of all these previous, soon to be this presentation, but all the, I think about 13 or 14 past adventures in crowdsourcing efforts. And again, along with our contractor support today from Grady Carrick and Amir Arista. But I want to remind everyone, we have a variety of crowdsourcing resources that we're here to support you through our Everyday Counts programs, workshops, peer exchanges. We offer technical assistance. I mentioned about the cohort web calls, and again, this webinar series. One of the things that we do is to provide technical support to various agencies, state DOTs, local agencies. So let us know if you have something in mind. We will kind of take a look at it and see if it kind of worth examining, just like this example here from MassDOT that we did last time in EDC 5. I mentioned to you about poll questions. That was brought up earlier, so we want to jump in there and kind of get some of your thoughts on this particular effort. If there's any new topics out there, anything new that we should share, what should we recommend to peers and other useful information to provide. So let's start with poll question number 1 in the very top right corner. What topics would you like to see in upcoming Adventures in Crowdsourcing webinars? And feel free to type your answer there. And once you finish that, feel free to go to the other 3 as well. One of them is, does your program wish to share, present, or present during an upcoming webinar? If yes, please enter your email. And would you recommend this webinar series to a friend, colleague? And we're going to do it on a range from 0 is not at all, and 10 is extremely likely. So anyway, I see some of the people changing their answers because they immediately went to the first one there. So feel free to scroll down. And finally, our last question is, how informative or useful were the presentations today, with 5 being very useful? And we'll keep this open for a little while. Again, we look for, if some of you have different ideas or thoughts of ways that you're using crowdsourced data or even the different tools. Again, we're not just limited to state DOTs. We welcome municipalities, counties, cities, transit agencies even as well, MPOs. We find a lot of MPOs that are involved as well. So we welcome your thoughts and input, and that's one of the efforts that we try to do is benefit others in this program. So if there's not any more questions here to be answered, and we'll keep the screen open. Just want to thank everybody again. My name is Ralph Volpe, one of the co-leads that I share with James Collier and Greg Jones. Both of them are with the Office of Operations at our Federal Highway Administration. So feel free to contact any one of us for questions, comments. because we really welcome and value your comments and input. It helps us do a better job and helps us direct our presentations to kind of help serve you all. So with that, we'll keep the screen open for a little while longer, but wish you all the best for the rest of the day, and thanks, and look forward to you joining us for cohort calls and also our next Adventures in Crowdsourcing webinar. Thank you very much.